Well, here we are, another day in calculus, and you can tell by the title, for some of you, it won't be your favorite day. Theorems in calculus, yes, it's about to happen now. There's some good news, though. Geometry, you know how that was the year of beat you down with the theorem, and even there was a few, I think, in pre-calculus when you studied polynomials. In calculus, everybody, there's only 4 or 5 big ones, and those are the ones that we use all the time. And so that's kind of nice, because if you get good at these 4 or 5, then you'll be just fine. And in all the math that you do. Now, you still might be wondering, well, why are they even here? You know, why can't we just math? Why do we have to do this? Well, to make a long story pretty short, that's it. They're used to help you justify the cool math that you're doing. Maybe I should put quotes around the word cool. But anyways, that's pretty much it. You know, in the real world, when something happens or you explain something or you know something, you know, how many times has somebody come back at you all snarky and been like, well, how do you know that? Well, you know, you can't just say, well, because I'm awesome. And you may try that, but it doesn't work. So you usually have to back up yourself to your crowd, you know. You have to tell them how you knew what you knew, and you're justifying yourself. You're proving yourself. And that's what this is going to do for you. It's going to give you a way to just say, I know this is true because of a theorem without you having to explain like 5 minutes, you know, of why it actually works. So we're going to start with the first one today, and the reason it falls in this chapter, it's going to feel like it doesn't have a lot to do with limits, okay? But this comes straight out of the whole idea behind continuity. So this is your first theorem, once again, inspired by continuity, okay? So I'm going to give you a minute to write it and to read it and to think about it, and then we'll kind of draw a picture here to go along with it. Okay, if that's not enough time, feel free to hit pause and then come back to me. But the intermediate value theorem, let me read it real quick. If f is continuous on the closed interval AB and k is any number between f of A and f of B, then there is at least one number c in the interval such that f of c equals k. Alright, so for a lot of people, you don't like to think about what this means, but I beg you to think through this, and that's why we're going to draw a picture so that it makes a little bit of sense. The first thing is we need to draw a continuous function, okay? F is continuous. So you could draw a line, you could draw a curve, it really doesn't matter. I'm going to draw something, okay, I'm just going to give it a little curve, but it really doesn't matter. And I need a closed interval AB. Well, it doesn't say where A and B are, but that's going to be a domain, so I just need to put them anywhere on the x-axis. So let's put A here and B here. Once again, it really doesn't matter where you put them, okay, but I just stuck them right there. And it's saying that K is a number between f of A and f of B. Okay, so let's think about that. Where would f of A be located? Well, f of A is just the y value that goes with A. So right up here where this hits the curve, that would be my f of A, and f of B would be where the B, the x value B, hits the curve. And it's just saying that k is some number between those two. So I'm going to look at it this way. Okay, this is a y value, right? This is a y value that goes with that. Here's the y value that goes with that, okay? So k is any y value between them. So honestly, I can put k wherever I want as long as it falls between those two y's. So I'm just going to choose here for funsies. There's really no particular reason here. So I'm going to call that k. All right. Now, what this theorem is saying is that there's got to be at least one number c in the interval. So keep in mind this is an x value. because they're mentioning it with the domain, okay, such that f of c is equal to k. So the y value that goes with c is going to equal that k. Well, let me draw this same dotted line all the way across here. All right, did you see that just happen? Okay. K, actually, this y value of k hits the curve here, here, and here, okay? But only one of those values fell within the mentioned interval. So between A and B, right here, okay, that is your k value, and it goes along with some c. That is all that this theorem is saying. And think about the title, Intermediate Value Theorem. It's just saying there's a value somewhere between two other values. When I learned this theorem, it wasn't until college, and I was a bad student. I started calling this the Noda Theorem, because that's pretty much what it feels like to me. It's like, yeah, I've got one y and I've got another y, and there's going to be a y in between them. And that is only possible, peoples, because of the word continuous, okay? And if it hadn't had the word continuous, this theorem would be just unusable, okay? So now that we have a picture and an explanation for this, let's talk about the purpose, how can I use this thing, right? So this is sort of the expectation of what you're going to be asked to do, and this would be a problem given, and after you write it and read it, feel free, like I said earlier, go ahead and hit pause, and everybody copy this down, and then come back and we will chat about it, okay? All right, so hopefully you've written this down, and we're going to talk about why this is a great intermediate value theorem problem, okay? We are asked to show or justify that there is a value c on the graph of f of x on the interval 0 to 5 such that f of c is equal to 1, and then it wants us to find the c. So the first thing is to understand that when it's mentioning a value c on the graph, that's going to be between these two. Notice the placement of c. C is in the spot where f of x normally is. So this is an x value, okay? So we're looking for an x value here, or we're trying to prove that there is one such that the y that goes with that is equal to 1. Okay, so this is a y value. C is an x value, okay? So how do we do it? So I want to think graphically, then we're going to do the algebra. Now graphically is easier for me, and hopefully you, if you're good at transformations. Let's sketch that graph. This is a parabola that's been reflected, and it's been shifted up 3 units. 1, 2, 3, and it's going down, something like that. Okay, now I don't want to take the time to think about exactly where it hits the axis, but I do know that for a parabola, the dilation is typically over 1, down 1, and then over 2, down 4. So I do know that it's going to cross the axis somewhere between 1 and 2. I further know just from my picture that I can see with my eyeballs that somewhere between 0 and 5 on the x-axis that I'm going to hit a y value of 1, right? Like a y value of 1, I could draw that dotted line like I did a second ago, and I know that it's right there. I see it with my eyes. So because this picture illustrates a value that's in between two other values, it's a perfect candidate for using the intermediate value theorem. So how can we actually do this without having to draw a picture and try to explain the theorem to someone? Well, it's pretty easy actually. To use the IVT, there's just a couple of steps, okay? So steps for using the intermediate value theorem to justify. It's actually really awesome. Step 1 is to take your interval given and actually find f of A and f of B. Now I called them A and B because, you know, they might change with any problem given. So for this problem, it means I need to find f of 0 and f of 5. Now how do we do that? Well, this is just algebra, folks. You know, f of 0, just plug a 0 in to your function. So we have negative 0 squared plus 3, which would be what, 3? And then we have f of 5, so we plug in negative 5 squared plus 3. So this is going to be 25, but it's negative, and then we add 3. So what is that? Negative 22, I think? Yeah. Okay. So you want to find your two numbers, okay? And then step 2, just make sure that the value in question is between f of A and f of B. So I hope you can read my writing, by the way. Make sure that the value in question is between f of A and f of B. So in other words, in this problem, it's asking me to show that f of C was equal to 1. So the y value they're giving me is 1. Is 1 between f of A and f of B? Why, yes, it is. Somewhere between those two numbers is the number 1. So that's all I have to do. If I show this, so what I would write is I would say, that would be it. I don't even really need words. I would just show f of 0 is 3, f of negative 5 is negative 22, and I would say, since f of x is continuous, that's a key, that's a big key, and f of A is less than f of C is less than f of B, and you know what, I actually may need to switch my inequality symbol here because I just looked at my numbers above, and f of A is actually the bigger one, right? 3 is the largest. So because f of C is between these other two, then according to the IVT, a C exists in the interval 0 to 5. That, ladies and gentlemen, is how you do it. And I know it's verbose and it's more than you're probably used to writing in the other math classes, but you're in the big leagues now and this is calculus, and you want to show some type of intelligence in your writing and your justifications, and this is exactly how I would do it. Okay. Now we're not finished with the problem. Lucky us. It says we want to go ahead and find the C value. Well, once you've done this, this is the hard part. You could have found C in the first 5 seconds of this. A lot of people are like, oh, I could have done that right off the bat. Okay, well, good for you. Let's do it. It just told us that the C value, or sorry, the Y value was 1, right? And remember the equation? It was, gosh, what was it? I think it was that, right? Okay, so that was the function in question. Well, if it's telling you find the x when y is 1, then plug in a dang 1 right here and find the x. So, you know, minus 3 from both sides. Maybe let's take the negative of both sides, or get rid of the negative on both sides. And then how do we solve that? Well, we just need to take the square root of 2. And I know it's plus or minus the square root of 2, but look at our interval. You know, our interval is 0 to 5. So our C is equal to the positive square root of 2 only because we're in that interval. So if they want you to go a step further and actually find the C, then that's what you would do. So hopefully this made sense and I wasn't too wordy for you. You can, of course, read in the book. If you want more support, you can always look for Khan Academy. I'm sure he's got some amazing videos over this as well. But I tried to do one video to wrap up the whole concept, including an example. So anytime you notice something's going on and there's a value in between two other values, please let the IVT come to mind. All right, have fun with this one. See you later.